Hi, I'm Papia, and in this problem we are going to compute the area of a region. Now, in this problem the region is not really given to us, but the problem says that the region is bounded by these curves, and then you have to compute the area of that region. So whenever you have these few curves given to you and you have to find area between them, bounded by them, I always suggest that first try to draw a sketch of that region. Then you will have an understanding, and then you can set up the definite integral that will give you the area. So why don't we start with each curve and figure out what the curve will look like, and then we can find the region. Okay, so first we have a 4 over x. Okay, we will look into that, but look at these other three. Do you see y equals 0, x equals 1, x equals e? Do you know what kind of curves they are? Well, they're just lines. Okay, what is y equals 0? Which line is it? You know that that's just x-axis, right? So y equals 0 is just x-axis. Okay, what is x equals 1? It's a vertical line through x equals 1. So say if this is 1, x equals 1 is just a vertical line, right? So this is your x equals 1 line. Okay, similarly, x equals e, where will that line be? Another vertical line through x equals e, and you know e is greater than 1, so say e is somewhere here. Okay, and so this is the other line. Okay, notice that the region will be bounded between these two. Y equals 0, which is x-axis, so this line. Okay, so this is y equals 0. And then 4 over x. Well, 4 over x, so notice that x equals 1, it's 4. So say starts here. At x equals e is 4 over e, so it's decreasing, right? So say something like this. So this is 4 over x. All right, so the region is bounded by all 4 curves. So what is the region? Right here. This is the region whose area you have to compute. Okay, so how do we compute this area? You know, definite integral gives us area, and this curve is positive, as you can see. So area will be just the definite integral between which x values? Well, 1 through e. Under which curve? 4 over x dx. That's the setup. And now you just find the antiderivative, then use fundamental theorem, and then you will have your area. So let's do that. Okay, how do we find the antiderivative? First, bring the 4 out, and then you will end up having 1 over x dx. Do you know what the antiderivative of 1 over x is? We all know that is natural log. Be careful, it is not just natural log of x, it's natural log of absolute value x. And then you just have to plug in 1 and e. So this is where we're applying fundamental theorem of calculus. You first plug in e, so natural log of e, and then subtract, and then you plug in 1. So 4 natural log of 1. Okay, these are all positive values, so you don't really need absolute value after you plug it in. And let's think about it. What is ln of e? That's just 1. What is ln of 1? Is 0. So the answer is 4. So this area is 4 square unit. Okay, so we finished the problem. Finally, we will have to use a graphing utility to check our result. So just pick up any graphing utility that you have, and let us plot the function 4 over x, and then graph it. And you see there are 2 branches of the graph, right? On the on the third quadrant and the first quadrant, but we are only looking into the first quadrant, which is okay. All right, so let us figure out the integral and see if integral 1 to e 4 over x dx gives us this area and it gives us 4 or not. So you can go to calc and go down to integral of f of x and enter, and then it's asking for lower limit, so plug in lower limit is x equals 1. Okay, enter, and then it's asking for upper limit, so plug in e. Okay, and then enter, and look, it's showing this exact area that we found before, and the answer is 4. So we have our work all correctly done. We found the area of the region bounded by these 4 curves. Thank you.